Hi, I'm Mark, and in this video we're going to talk about the 5 perfect solids. Here they are. We also call them the Platonic solids because Plato was a Greek guy who loved them. And they're perfect for the simple reason that each face is the same as every other face. Each edge is the same as every other edge, and every point is identical to every other point. That's what makes a solid perfect. There's only 5 of them in the entire universe. Now, this is the kind of thing that everybody should know, but nobody does because they don't teach it in school. But we're going to learn it here, and then we're going to apply it to our love of golf and just have that much more fun on the golf course. Let's start out by naming the 5. This is a tetrahedron, octahedron, hexahedron, icosahedron, dodecahedron. Now those are named based on the number of faces. 4 tetra, 8 octa, 6 hexa, 20 icosa, and 12 dodeca. Now these are arranged by the number of points. Okay, this has 4 points, 6 points, 8 points, 12 points, 20 points. The first thing that the alert viewer is going to notice is that the number of faces and points on these 2 objects are flipped around. 8 faces, 6 points, 6 faces, 8 points. That's called a dual. And you get that by taking the center of each face and putting a point right in the middle of it. So if we do that for both of these objects, we get this. 8 points, 6 points, 14 points. Each one of these red points is right in the middle of 4 blue points. Each one of these blue points is right in the middle of 3 red points. So the octahedron and the hexahedron are dual to each other. The same is true for the icosahedron and the dodecahedron. And when we do that, we get an icosahedron, which is 32 points. 20 purple ones and 12 green ones. Each green one is right in the middle of 5 purple ones, or a pentagon, and each purple one is right in the middle of the triangular green ones. We call that an icosahedron. We all recognize that as a soccer ball. A soccer ball has 20 panels that are white and hexagonal, and 12 panels that are black and pentagonal. We all recognize that. That's an icosahedron. We see that same pattern on a lot of the dimple patterns of golf balls. Now, the one that we haven't discussed is the tetrahedron, and it's pretty cool too, because if we put a point in the middle of each of these faces, we get another tetrahedron. So the tetrahedron is dual to itself. We can see that here. 2 purple tetrahedrons. Now if we break that down and we put a color on each point, then we take the purple points and put a color on each triangle, we get this, which is, as you can see, a cube. So the 8 points of dual tetrahedrons are the same as the 8 points of the cube. So a tetrahedron dual to itself forms a cube. Now we can start to see a pattern emerge here. We take 2 tetrahedrons, make them dual, and we get a cube. And what's even cooler is if we take 5 of these cubes, wrap them around like this, which is the same as the icosahedron, you guessed it, we can get a dodecahedron. So now we can start to see the relationship between all 5 perfect solids. They're not just random, they're all interrelated. 2 tetrahedrons makes a cube, 5 cubes makes a dodecahedron, which, do the math, that means that 10 tetrahedrons make a dodecahedron. Now that's pretty cool, and we can start to use those when we make the jigs to color our golf balls. And then one more point that is true for 4 of these solids is that every point has a complement exactly opposite on the ball, which is kind of like a axis of rotation. So each one of these 4 objects has a rotational axis that goes through 2 points. And we can use that also when we identify our golf balls. The tetrahedron doesn't, but as we've seen, when you put the exact opposite on the tetrahedron, you get the cube. So we can also use that as well on the jigs. So Now that we have a general basic understanding of these perfect solids, we can use their form to equally space points on the surface of the golf ball, and that makes us a lot cooler than our friends who can't do that.